Now we are looking at gradients, tangents, and normals. The first question, find the equation of the tangent to the curve y equals x cubed at the point 1, 1. So the graph of y equals x cubed is going to look something like this. A tangent is a straight line that just touches a curve. It doesn't go through it. So at the point 1, 1, we're going to have a tangent that looks something like this. So a straight line that just touches the curve at the point 1, 1. The tangent has the same gradient as the curve at this point. And because the tangent's a straight line, it will have that gradient the whole way along the line. So to find the equation of a tangent, we need to find its gradient. And to do that, we find the gradient of the curve using dy dx, our gradient function. So y is equal to x cubed. So dy dx, our gradient function, is equal to 3x squared. We times by the power and then take one off the power. So at 1, 1, when x is 1, dy dx is 3 times 1 squared, which is 3. So the gradient at this point is 3. So the gradient of the tangent is 3. How do we find the equation of a straight line given the gradient and a point? We could use y equals mx plus c and substitute in to find c, or we can use y minus y1 equals m times x minus x1. So x1 and y1 are both 1, so y minus 1 equals 3 times x minus 1. That is the equation. If we want to, we can rearrange it to put it into the form y equals mx plus c. So expand the bracket and then add 1 to both sides. So y is 3x minus 2. Y equals 3x minus 2 is the tangent at the point 1, 1. Here's one for you to try. Pause the video and give it a go. So again, we're finding the tangent at a point. So this time we've got a quadratic. But it's the same thing. We've got a tangent which just touches the curve. And the gradient of the tangent is the same as the gradient of the curve at that point. So we can find the gradient using dy dx. So dy dx this time is 2x. And when x is 2, dy dx is going to be 2 2's, which is 4. So we've got a gradient of 4, and we've got the point 2, 4. So x1, y1, and m. So y minus y1 equals m times x minus x1. Y minus 4. So that is the equation. I'm going to rearrange it. I'm going to put it in the form y equals mx plus c. So I'm going to plus 4 to both sides. So y equals 4x minus 4. Find the equation of the tangent to the curve y equals x squared plus 2x minus 15 at the point 4, 9. So again, we're going to find the gradient at that point using dy dx. So the gradient times by the power, take 1 off the power. We've got 2x plus 2 is the gradient function. And when x is equal to 4, our gradient is 2 4's plus 2. which is 10. So the gradient of the tangent will be 10, and it goes through the point 49. So we've got a set of coordinates, and the gradient. So we can use y minus y1 equals m times x minus x1. And again, we can rearrange to put it in the form y equals mx plus c, or the form ax plus by plus c equals 0. So y is equal to 10x minus 31. And one for you to try. Pause the video, give it a go. So we're finding the equation of a tangent. So dy dx, 3x squared plus 2x minus 6 is the gradient function. And we want the gradient when x is 2. So dy dx at that point, 3 times 2 squared plus 2 2's, take away 6. So that's 3 times 4 is 12, plus 4 is 16, take away 6 is 10. So we've got a gradient of 10, and the point 2, 0, which is x1, y1. So y minus y1 equals m times x minus x1. So y is equal to 10x minus 20. Find the equation of the normal to the curve, y equals x cubed, at the point 2, 8. So a normal is perpendicular to the tangent, perpendicular to the curve at that point. So y equals x cubed is this graph. We've got a point here, 2, 8. So the tangent has got the same gradient. So this would be the tangent. The normal is perpendicular. So it's at a 90-degree angle. To find the equation of this line, we find the gradient of the tangent, the gradient of the curve at that point, and then do the negative reciprocal, flip a minus, to find the gradient of the normal. So dy dx, to find the gradient of the curve at that point, that's 3x squared. When x equals 2, dy dx is 3 times 2 squared, which is 12. So that's the gradient of the curve of the tangent at that point. We don't want that, we want the normal. So it's the negative reciprocal. So it's going to be negative 1/12. That's going to be the gradient of the normal. And it goes through the point 2, 8. So we've got x1 and y1 and m. Y minus y1 equals m times x minus x1. And this time I'm going to put it into the form ax plus by plus c equals 0. So I'm going to multiply by 12. So 12y minus 96 equals negative 1 times x minus 2. So 12y minus 96 equals minus x plus 2, and make it equal to 0. So I'm going to have x plus 12y minus 98 equals 0. So that is the equation of the normal at that point. One for you to try. Give it a go. So dy dx is 2x, and when x is 3, dy dx is 2 3's, which is 6. So the gradient of the tangent is 6. The gradient of the curve at that point is 6. But we don't want that. We want the normal. So that's the perpendicular line here. So the gradient is a negative reciprocal, which is negative 1/6. And we've got a 0.39, so x1, y1. So we can say y minus y1 is m times x minus x1. I'm going to times by 6, so 6y minus 54 equals negative x minus 3. 6y minus 54 is negative x plus 3. And I'm going to make it equal to 0. So x plus 6y minus 57 equals 0. So that is the equation of the normal at that point. Find the equation of the normal to the curve y equals x squared plus 3x minus 10 at the point 3, 8. So again, dy dx, which is 2x plus 3. When x is 3, dy dx is 2 3's plus another 3, which is 9. That's the gradient of the curve at that point. We want the perpendicular line. The normal is perpendicular. So the gradient is a negative reciprocal minus 1/9. And we've got the point 38. So x1, y1. Y minus y1 equals m times x minus x1. So 9y minus 72 equals minus x plus 3. I've multiplied the bracket by -1, and I've times both sides by 9. Now I'm going to make it equal to 0. So plus x to both sides. Take away 3 from both sides. And that is the equation of the normal. One for you to try. So dy dx again, which is 2x plus 5. When x is 2, dy dx is 2 2's plus 5, which is 9. So the gradient of the normal is a negative reciprocal, minus 1/9. And we've got x1, y1. So we've got a point on the straight line and the gradient of the straight line. So y minus y1 equals m times x minus x1 times by 9. Expand the bracket, make it equal to 0. So x plus 9y minus 74 equals 0.